Microcytic hypochromic anemia, मोस्टली आयरन डेफिशिएंसी एनीमिया के साथ ये टर्म होती है. स्मॉल साइज माइक्रोसाइटिक हाइपोक्रोमिक पेल इन कलर बिकॉज ऑफ less iron, less hemoglobin, and after all, RBCs है क्या? They don't have any nucleus, they do not have any mitochondria. They are bags full of hemoglobin. तो hemoglobin ही नहीं होगा तो साइज स्मॉल हो ही जाएगा. अभी हम थोड़ी कंडीशंस एक दो और डिस्कस करेंगे. Although this term is mostly iron deficiency anemia should come first to your mind. But there are 2 or 3 more deficiency disorders also where this type of anemia can occur. Number 1, deficiency of vitamin B6. All of you know name of this enzyme, pyridoxal phosphate. It is coenzyme for a number of reactions, and one of the for a number of reactions for a number of enzymes, I mean to say, and one of those enzymes is ALAS abbreviation, ELA synthase, which synthesizes first intermediate of the heme biosynthetic pathway. The first intermediate of heme biosynthetic pathway, the reaction is something like this. Smallest amino acid glycine, an intermediate of TCA cycle, succinyl coenzyme A, condense together to form ELA, delta amino levulinic acid. And ELA synthase is the enzyme for this reaction. And after that, you will learn later, or maybe you know also, after a long series of steps, there is formation of heme. Long pathway, partially mitochondrial, partially in the cytosol. But important point is that the first enzyme of this pathway, the regulatory enzyme, the committed enzyme, the rate limiting enzyme of heme biosynthetic pathway is catalyzed by ELA synthase, for which PLP, B6 is the coenzyme. So now we take the reverse here. Agar B6 nahi hoga, then what will happen? Activity of ELA synthase will fall. So ELA synthase activity fall ho gayi. The result will be the first reaction will become sluggish, and then heme synthesis will also fall. So heme synthesis fall ho gayi. Of course, the result will be microcytic hypochromic anemia because of the reasons we just now mentioned some time back. RBCs bag full of hemoglobin. So no heme, iron does not have any heme to bind with. So microcytic hypochromic ho jayega. But there is one important difference I may highlight. Serum iron level, plasma iron level is low in iron deficiency anemia, but here the iron will remain unutilized. So serum iron level will not fall. So that is the major difference from the that iron deficiency anemia. One more difference. The unutilized iron, we said iron remains unutilized. The unutilized iron in the bone marrow, it enters the precursors of RBC, the erythroblasts. So erythroblasts are laden with iron, the surplus iron, and this erythroblast laden iron-laden erythroblasts, they are called sideroblasts, and thereby this type of anemia is also called sideroblastic anemia. Sideroblastic anemia because of deficiency of B6. So first B6 हमने discuss कर लिया. Second, vitamin C, ascorbic acid. How deficiency of this vitamin leads to microcytic hypochromic anemia? Again the same thing, by causing iron deficiency. You see, iron is present in our food, but mostly it is in the ferric form. It is also present in the utensils which we use, or used to use for cooking. So उसके अंदर भी iron होगा, but that iron is present in the ferric state. And you people also know, I'm sure, that intestinal absorption of iron can occur only in the ferrous state. So dietary iron ferric has to be converted to ferrous, and that is done in the intestine. HCl plays an important role. Vitamin C also plays important role in causing ferric to ferrous conversion. So iron absorption कम हो गई, उससे क्या होगा? Again the same thing, less hemoglobin, microcytic, hypochromic, anemia. So taking the reverse gear once again, deficiency of vitamin C, this conversion is impaired. Impairment of this conversion will result in less absorption of iron. So we have discussed B6, C, vitamin C deficiency. Now we come to a mineral, copper. Copper deficiency also leads to hypochromic microcytic anemia. How, that we are going to see, and this is indistinguishable from iron deficiency anemia in every way except one. We are going to talk about it. You know, this copper, this is an important component of a protein called ceruloplasmin. What is role of this protein ceruloplasmin, of which copper is an important component? If you said transport of copper, you're wrong. The predominant role of this protein ceruloplasmin, it possesses ferrooxidase activity. It possesses ferrooxidase activity, means it causes conversion of ferrous form to ferric form. And this conversion plays an important role in iron homeostasis. I may add one thing before proceeding further, that iron metabolism is, iron homeostasis is regulated at the intestinal level, intestinal absorption level. Now I return to ceruloplasmin. What does it do? Ferric to ferrous conversion करता है ये, and this ferric form is incorporated into apotransferrin to cause transferrin, the iron transport protein, and then transferrin carries this ferric iron to various tissues where it is incorporated in apotransferrin to form transferrin. Transferrin receptors are there in the various tissues where iron is utilized. So, agar ferrous to ferric conversion nahi hua, so less will be the formation of transferrin and less will be the utilization of iron. So, what will be the result? Iron deficiency, and therefore the same thing. But only one difference, as I said, the difference is copper deficiency anemia. Although indistinguishable from iron deficiency anemia for being microcytic, hypochromic, etc., but a very big difference is it is not responsive to iron therapy, unlike iron deficiency anemia.